Hello, grade 11s. In today's lesson, we're going to be looking at Newton's law and we are doing acceleration and tension question, the simultaneous type. I've been getting a request from you saying, how do we deal with this acceleration and tension question where we see 6 marks, it involves simultaneous equations. So in today's lesson, worry not, I'll be showing you a simple and very easy way to tackling those questions. And without any further ado, let's get right down to the lesson. So now we are given question 4. It says a 6 kg block held at rest on a rough horizontal table is connected to another block of mass 3 kg by a light inextensible string passing over a frictionless pulley. The 3 kg block hangs vertically as shown in the diagram below. Then we can see the diagram there. They say when the 6 kg block is released, it accelerates to the right and experiences a kinetic frictional force of 24 Newton. So we note that we've been given the frictional force of 24 Newton, and then they say ignore the effect of air friction. Now 4.1 says state Newton's second law of motion in words. So let's run quickly to that. We say Newton's second law states that when a net force is applied to an object of mass, the object will accelerate in the direction of the net force, where the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Right. Now 4.2 says draw a labeled free body diagram showing all the forces acting on the 6 kg block. So now we want to observe all the forces in here. So we can see that because the earth is exerting a force, on this object, we know that every object has a gravitational force. So and this object is on the surface. That means it is experiencing normal force. Remember, normal force is the force exerted by the surface on an object, and then it acts perpendicular to the surface in which an object is placed. Then we have a string there. We know that when we have a string, we have tension force, right? So this is the force as a result of a string or rope that is connected to an object, right? And then we are told that this block, 6 kg block, accelerates to the right, and then it is on a rough horizontal surface. That means it is experiencing a frictional force. As we've been told, it experiences a kinetic frictional force of 24 newtons. But then remember, frictional force always acts in the opposite direction of motion. So when the object is going to the right, frictional force is going to the left, right? Now that's how you have all the forces. Now let's come to drawing the free body diagram. This is how we'll now draw the free body diagram. Excuse me. Then that's your FG, right? Acting downward, and then upward. There you have your normal force, and then to the right you have your tension force, and then moving to the left you have your kinetic frictional force, so it's Fk. And that for 4 marks. Remember, your marks are showing you how many forces you should put in there, right? So awesome. Now we have 4.3, calculate the magnitude of the acceleration of the 3 kg block, 6 marks. Now this forms the basis of what the lesson is about today. So calculation of magnitude of the acceleration for 6 marks. Now we know this question here will involve simultaneous equations, whereby we won't have the value of the tension, and we are also looking for the value of the acceleration. So we know once you have two unknowns, that's where you have simultaneous equations. Now you will note one thing with these questions, you will always be given two objects, right? And then in your question, you'll only be asked to draw a label-free body diagram of one of the objects. Now, if you want to succeed in answering these questions, the tip I'm going to give you is you should also draw the free body diagram for the other object, right? So now we only have the free body diagram for the 6 kg block. Let's try now to draw the free body diagram for the 3 kg block. So alongside, let's try to draw the free body diagram of the other one. So we had Fn, we had Fg, and then here we had tension, and then that's our Fk. Then alongside, let's try to draw. We have tension for the 3 kg block, and we have Fg. Now, because this is moving downward, right? The block is moving downward. We will have our Fg being slightly longer than the tension, right? To indicate that the object is experiencing a gravitational force, hence it is pulled downward. Now, let's indicate the directions. Because the 6 kg block is moving to the right, we say the right is our positive direction. And the left has to be our negative direction, since it is opposing the motion of the object, right? Then here, the 3 kg block is going downward, so we assign positive to the direction of motion, and the one that is against the direction of motion is negative. Now, once you have your two free body diagrams, it becomes very easy to calculate. Now, remember, the 6 kg block is moving horizontally, right? So that means when calculating our Fnet, we only consider horizontal forces, since we say this object is moving horizontal. But then for the 3 kg block, we can see that it is moving vertically, and there are no horizontal forces here. So for the Fnet of the 3 kg block, we will consider the vertical forces. Now let's do that, and let's see what I'm talking about. Now I'm gonna indicate here for 6 kg block. So you want to write in a way that you don't confuse yourself and the marker. Then Fnet is equals to MA. Now remember, we assigned tension the positive direction, so we will have T minus Fk, and then it's equals to MA. And you will note that we are not given the magnitude of tension, so we have T, but we are given the magnitude of the kinetic frictional force. From the statement, they said it's 24 newtons, right? Then what is the mass? The mass is 6. So we have 6A, and then now we have T. So let's make tension the subject of the formula. We have 6A plus, and transposing that negative 24, it becomes plus 24. And then we call this equation 1. So you have your first equation. Let's go and create the second equation, right? So now you go again for 3 kg block. For 3 kg block, this time around you have Fnet is equal to MA, right? Then remember, which one was positive? We said the object is going downward, so Fg is positive now because it's in the direction of motion. And then what is negative is the tension, so we say minus T, right? Because it's going against the direction of motion, then MA. Then you will remember that our gravitational force can be written as mass times the gravitational acceleration. So let me write that nicely. So it's m times g minus tension is equals to MA. Now, what is the mass? We say the mass is 3, and then multiply that by 9.8. Then we have minus tension, and then again this side the mass is 3, and then we have 3A, right? At this point you can just multiply 3 times 9.8. That gives you 29.4, and then minus T is equals to 3A. Now, you can choose to make this equation 2, but what I like to do is just to make T also here the subject of the formula. But because I see T is negative, I'll just transpose it to the right hand side. Then take that one and transpose it to the left hand side. So I have 29.4 minus 3A is equals to T, and then that will become my equation 2. Now, if you can check here, my equation 1 is in the form of T, and then also my equation 2 is in the form of T. That means if I have T, all these equations expressed in the form of T, I can equate the two equations, right? So now I can say equate equation 1 and equation 2. Remember, they're all expressed in the form of T. So in this case, I have 6A plus 24 is equal to 29.4 minus 3a. Then at this point, you want to have all your like terms on the same side, and then all your constants on the same side again. Then now you have 6a plus 3a, that gives you 9a, and then 29.4 minus 24, that gives you 5.4. And then to calculate your acceleration, you divide both sides by 9. Then your acceleration is equals to 0. Let me write that. So it's 0.6 meters per second square. So 0.6 meters per second square. And that's how you tackle that one. Nice. Now, let's look at the last question. It says, explain the following statement. The acceleration of an object is 0.6 meters per second. So how do we explain that one? Coming to explaining that one, we say that means that the velocity, so for 4.4, we have the velocity. The velocity changes by 0.2 meters per second for every second. Now, how do we come about with this one? We know that acceleration comes from the formula. Acceleration comes from the formula here. Acceleration is equals to change in velocity over the change in time, right? So this 0.6 meters is the same as us having 0.6 meters per second for every second that passes, right? So that's it. So we have 0.6 meters per second that passes. So that's the velocity of the object per second. Now let's look at question 4. In the diagram below, a 5 kg mass on a rough horizontal surface. Now we know once we see that rough horizontal surface, we know that there's friction involved. Then rough horizontal surface is joined to a 3 kg mass by a light inextensible string running over a frictionless pulley. The system is initially at rest, right? Initially, it was at rest. Now they say the kinetic friction between the 5 kg, if you note that word, the kinetic friction, that means now the system is no longer at rest. Once you have kinetic friction, remember kinetic friction is the friction that opposes the motion of a moving object. So once they say the kinetic friction between the 5 kg and the surface, they give you the value, then you already know the system is no longer at rest, it's now moving, right? So initially it was at rest, but now it is moving, hence it is experiencing kinetic friction, right? Then 4.2 says draw a free body diagram showing all the horizontal. So you need to read your statements correctly. So you can see that's 2 marks, right? So they only want you to show the horizontal forces acting on the 5 kg mass. So if we consider horizontal forces here, we can see that one thing that we see is the string here. Then we know once we see the string, that's tension, right? And then this block is accelerating to the right, so that means your FK is acting to the left. So how do we know that it is accelerating to the right? We know that this block here is pulling the system downward, right? So obviously 5 kg has to be moving to the right. Therefore, the FK acts to the left. So indicating that drawing a free body diagram now, we have the dot to indicate the object. And then this side we have tension. That side slightly smaller, we have FK, right? So, and that's how you have your free body diagram. Awesome, 2 marks. Then 4.2, calculate the acceleration of the system. Now you will remember that I said when it comes to calculating the acceleration of the system, and you see there, so for this one, unfortunately they just gave us 4 marks, but then it still requires you to do simultaneous equations. You can see why, because there are 2 blocks there, and then you can see these 2 blocks are connected by a string, right? Meaning they move as a system, and they say calculate the acceleration of the system. So that's the acceleration of the 5 kg and the 3 kg all together, right? Then this is how you do it now. You must draw the free body diagram of the other object, right? So in order to successfully answer this question, draw the free body diagram also of the 3 kg block. So we have that. And then remember, we said the object is moving downward, so our FG will be slightly longer than the tension, right? To indicate that the FG has power over tension. That's why the force, the object is going downward. So we have plus here, and then we have minus. Plus for the direction of motion, plus for the direction of motion, minus or negative for the opposite direction of motion. Now that you have your 2 free body diagrams like that, remember here, even if we don't indicate for this one here, even if we don't indicate the vertical forces, they do not form part of our FNet because eventually they cancel out. Remember, if it is moving horizontally, the only forces we focus on are the horizontal forces. If it is moving vertically, the FNet is formed by the vertical forces. Now let's go. So we have FNet. Now let's indicate for what? For 5 kg block. So for 5 kg block, we have FNet is equal to MA, right? Then we have tension minus FK, and then MA. Then we are not given the value for tension, but we know the value for FK. We've been given on the statement. They said it's 4.5, right? Then what is our mass? It's 5, and then we have A there. Now, to calculate our tension, we have T is equals to 5A plus 4.5. Then we call this our equation 1, right? So that's it for the 5 kg block. Now let's move to the 3 kg block. Now we also indicate for 3 kg block. For 3 kg block, this time we have FNet is equal to MA. Then our direction of motion is in the side of FG, so we have FG minus T is equals to MA. But remember, FG is mass times the gravitational acceleration, so minus T is equals to MA. What is our mass? It's 3, and then times 9.8 minus T is equals to 3A. Now 3 times 9.8 gives us 29.4. Punch that in your calculator, and then it's equals to 3A. Now again, I want to make T the subject of the formula, so I take my T and transpose it to the right hand side. So now I have 29.4 minus 3A is equals to T, and this will form my equation 2, right? Now at this point, because equation 1 and equation 2 are expressed in the form of T, what can I do now? I can equate the 2 equations. So now I say equate equation 1 and equation 2, right? Now what do we have? When we equate the 2, now we have 5A. When we equate the 2, we have 5A plus 4.5 is equal to 29.4 minus 3A. Now we want our like terms to be on the same side, so we have 5A plus 3A is equals to 29.4 minus 4.5. Now what is 5A plus 3A? That gives us 8A. Then we have equals 29.4 minus 4.5. That gives us 24.9. And then when we divide that both sides, so let's see, 29.4 minus 4.5. Yes, and then divide both sides by 8. Divide both sides by 8. Now our acceleration is that divided by 8, we have 3.11. Round off to 2 decimal places, meters per second square, right? So 3.11 meters per second square, right? And that's how you tackle that one. Then 4.3 says describe the motion of the 5 kg block. Describe the motion of the 5 kg block when the 3 kg block lands on the floor. Assume that the 5 kg block does not reach the pulley, right? So now what is happening here? If this one goes all the way and lands here, now what will happen to this 5 kg block if it doesn't reach this part? So we say the velocity. So for 4.3 we say the velocity will decrease. Obviously when this one is down, it's no longer exerting that maximum tension force there. So velocity will decrease until the 5 kg block comes to rest. So we say that the velocity will decrease until the 5 kg block comes to rest. So that's what will happen there. So we are given question 4. It says a 6 kg block on a horizontal rough surface is joined to a 2 kg block by a light inextensible string running over a frictionless pulley. The frictional force between the 6 kg block and the table is 11.76, right? And then a downward force of 2 Newton is applied. So we can see we have an applied force there to the 2 kg block as indicated in the diagram below. Now 4.1 says state Newton's second law of motion in words. So let's run quickly to that. We have 4.1. Newton's second law states that when a net force is applied to an object of mass, the object will accelerate in the direction of the net force, where the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Right, and that's your free 2 marks like that. Now, we have 4.2. It says draw a free body diagram showing all the forces acting on the 6 kg block. So now let's observe all the forces acting on the 6 kg block. We know because the earth is exerting a force on this object here, it is experiencing a gravitational force, right? So we have Fg. And then because this object is on the surface, we know that the surface is exerting a force on this object, which is called the normal force. And then we can see a string there, or a rope, that is exerting tension force. Remember, force by a string or a rope is tension force. And then we are told that there is frictional force. So because the object is going to the right, that means the frictional force will act to the left, right? So it's kinetic frictional force. And then we've been given the value to be 11.76. So now let's draw the free body diagram. That means coming to drawing the free body diagram, we have our dot here to indicate the object. And then our upward force is normal force. And then we have a downward force and the gravitational force. And then to the right, we have our string tension. And then we have our kinetic frictional force. And then there you have it, 4 marks for that free body diagram. Then 4.3 says calculate the magnitude of the acceleration of this 6 kg block. Now again, here we have a simultaneous type question. You can see it's 5 marks. We are required to calculate the magnitude of the acceleration, and we do not have the magnitude of the tension. So remember, the strategy that I gave you is you have to also draw the free body diagram for the other object, right? For the other block, right? So now we can see with this block here, there is something interesting about this block here now. How many forces are acting in this block? We can see there is a rope here, so there is tension. And then there is an applied force downward here. They say a downward force of 2 Newton is applied to the 2 kg block. but the 2 Newton applied force is not the only force that is going downward. We know that we also have the gravitational force. So now, having to draw this, we know that there are 3 forces there involved. So now we have the tension upward, and then remember now the FG has to be slightly longer than the tension, then because it's going downward. So also we have our applied force, right? So 2 forces are going downward, the applied force and the gravitational force, and then only 1 force is going upward, the tension. So for this one, we have 3 forces, so you had to note that. Now, having that, let's indicate our directions of motion. So it is going to the right, the object is going to the right. So to the right, we assign positive, and then to the left, we assign negative. But then it's going downward. The 2 kg block is going downward. So we have plus here, then we have minus in the opposite direction of motion. So now let's continue. Calculating for our F net, we'll say for 6 kg block, let's indicate for 6 kg block. Remember now it's going horizontally, so we only consider horizontal forces. So we have F net is equals to MA, right? Then we have T minus the kinetic frictional force is equals to mass times acceleration. Then our kinetic frictional force, remember we've been given in the statement and they said it's 11.76. And then what's our mass? It's 6, and then we have 6A like that. Then tension is equals to 6A plus 11.76. Then we'll call that equation 1. Now let's get to the 2 kg block. Let's calculate for 2 kg block. We have F net is equals to MA. Then now remember we said 2 forces are going downward. That's your FG and your force applied. Then we have minus tension. This is equals to mass times acceleration, right? Then your FG, we know it's M times G. Then we'll say plus FA minus T is equals to MA. Now let's substitute everything. We have the mass is 2, and then multiply by 9.8. And then the force applied is 2 Newton. Minus T is equals to the mass is 2, and then we have 2A. So now we have 2 times 9.8 plus 2. That gives us, that now gives us 21.6, right? Minus T is equals to 2A. Now remember, we can make T the subject of the formula by transposing it to the right hand side. Now we have 21.6 minus 2A is equal to T, and this can form our equation 2. Now since both equations, equation 1 is expressed in the form of T and also equation 2 is expressed in the form of T, what can we do now? We can equate the 2 equations, right? Now this is what we have. We're gonna have 6A plus 11.76 is equal to 21.6 minus 2A, right? Now at this point, what do? We can take the minus 2A and transpose it to the left. Then we have 6A plus 2A. So all the like terms in one side and all the constants in one side. Then 6A plus 2A is 8A. Then 21.6 minus 11.76, that gives us 9.84. Then we can divide both sides by 8. Divide both sides by 8. Then our acceleration is 1.23 meters per second square. Right. Awesome. Then now let's have a look at 4.3.2. It says calculate the magnitude of the tension in the string connecting the 2 blocks, right? So that for 2 marks, let's calculate. So now that you have the acceleration, it becomes easy. you can just pick any equation, equation 1 or equation 2. Then let's say we are picking equation 1. We have 6a plus 11.76. But remember, we have calculated the acceleration to be 1.23. So we substitute in the position of a, and then we have that 11.6. And then when you add those, punch that in your calculator, it's 19.14 Newton. And that's the magnitude of the tension. Awesome. Then we have 4.4. It says the rough surface is replaced by smooth, frictionless surface. How will this change affect the answer in question 4.3.1? Right, only increase, decrease, or remains the same. So now we know if we replace a rough surface by a smooth surface, the object will move freely, right? So now when it moves freely, that means what happens to the acceleration? Obviously, the acceleration will have to increase, right? So for 4.4, we say the solution is increase, right? So there will be an increase in acceleration. And now we have question 4. It says the sketch shows a block of mass 2 kg placed on a rough horizontal surface. This block is attached to an 8 kg mass by an inextensible cord that passes over a frictionless pulley. The frictional force between the surface and the 2 kg block is 10 Newton when the block is in motion. So we've been told that the frictional force is 10 Newton when the block is in motion. That means that we are looking at the kinetic frictional force, right? Now 4.2 says draw a labeled free body diagram showing all the forces acting on the 2 kg mass piece, right? So let's look at the forces that are acting on the 2 kg. The 2 kg has the gravitational force, and then because it is on the surface, we know it has normal force, and then because of that string there, we know that it is experiencing tension force, and then we've been told that it experiences frictional force. So this is Fk. Remember, your frictional force is always acting in the opposite direction of motion. The object is moving to the right, therefore your frictional force will act to the left. Then having to draw our free body diagram, let's go now. So we have the dot to indicate the object. Then we have our normal force going upward there, and then our gravitational force, force exerted by the earth on the object going down, and then we have our tension force to the right and our frictional force to the left. So that's how you have it. 4 marks like that in the bag. Now 4.2 says calculate the acceleration of the 8 kg mass, and we are given 5 marks for that question. So again, you can see they say the acceleration of the 8 kg mass, but we know in true fact we are calculating the acceleration of the whole system, because the acceleration of the 8 kg mass is also the acceleration of the 2 kg mass, right? So in this case, this is also a simultaneous type question, whereby now we'll have to find the F net of both the objects. Now remember, the advice that I gave you with this one is that when they say draw a label free body diagram of one object, you also need to draw the other free body diagram, right? So now we will have to draw the free body diagram of the 8 kg block. So alongside, let's just draw it there. Remember, you don't have to draw it on your answer sheet, just by the side, so that you know that you use it for calculation. So the one that will be marked is this one, right? Because they asked you that. But then just on a piece of paper or on your question paper, you can just draw the other one, right? Because you need both the free body diagrams in order to calculate. Now let's indicate our directions. So we have positive in the direction of motion and negative in the opposite direction of motion. So this one, it's going downward. As we can see, the Fg is longer than the tension. We don't have normal force here, it's tension force. Pardon me there. Then tension. So this one will be negative, right? So now what do we have? It says the acceleration of the 8 kg mass, right? So what do we do? Let's begin. We say for 2 kg mass, let's calculate the F net. So we have F net is equal to ma. So now for the F net, looking at the horizontal forces, we have T minus Fk is equal to the mass times acceleration. We don't have the tension as expected, but then we do have the kinetic frictional force is 10. Then the mass is 2, so we have 2a. And then making T the subject of the formula, we have 2a plus 10. That gives us our equation 1, right? Now let's go and let's check the 8 kg mass. So we indicate for 8 kg mass, then it is the one that is hanging there. So we have F net is equal to ma. And this time around we have Fg minus tension, right? And then ma. Then our Fg can be expressed as the mass times the gravitational acceleration, that minus T. And then our mass is 8. Multiply that by 9.8. Then say minus T, we have 8a. Then if we express that, let's multiply 8 times 9.8. We have 78.4 minus T is equals to 8a. Awesome. Then let's express this in terms of T. So making T the subject of the formula, we'll have to take it from the left hand side and throw it on the right hand side. So we have 78.4 minus 8a is equals to T. So this will form our equation 2. Now that you have these two equations expressed in the form of T, you have equation 1 expressed in the form of T, and then also equation 2 expressed in the form of T. That means you can equate the two equations now. So we go equate 1 and 2. So equate equation 1 and equation 2. Right. So what do we have now? Let's equate that. We have 2a plus 10 for the first expression, and then 78.4 minus 8a for the second expression. Now, if we look at this, we can just arrange the like terms on one side. So 2a plus 8a. Then this side we have 78.4 minus 10, right? Now 2a plus 8a gives us 10a. Then is equals to 78.4 minus 10. We have 68.4. Then we divide both sides by 10. When we divide both sides by 10, our acceleration, punch that in your calculator, it gives you 6.84 meters per second square. So never forget the SI unit. Remember, if you don't put in your SI unit, you forfeit a mark. Now, 4.2.2 says the tension in the cord, and that for 2 marks. So remember, now it's easy to calculate the tension when you already have the acceleration. You just choose which expression you want to use. You can use equation number 1, or you can use equation number 2. So in our case, let's just use equation number 1. But then using either equation will give you the same answer, because remember, you said the two equations are equal. So we have 2, and then in the place of a, we have 6.84. Remember, we calculated it in the previous question. Then punching that in your calculator, you now have 23.68 newtons. Remember, tension is a force, so the SI unit is newtons. All right. Now let's go to 4.2.3. It says calculate the distance the 2 kg mass will travel in 1.2 seconds if it starts from rest. So what are we given there? Let's highlight the data we've been given. We've been given the time 1.2 seconds, and we've been given that it starts from rest. What does start from rest tells us? It tells us that the velocity initially is 0, right? So collecting our data, what are we given there? We are given change in t, which is 1.2 seconds, and then we are given vi, which is 0 meters per second, and we are looking for delta x, remember the distance, right? Now if you can check this, you can see this is a throwback question because we'll be applying equations of motion way back from grade 10, right? So now this is how we go. So this is where we get to see if you deserve to be in grade 11 or you just skipped grade 10. That's the joke, guys. Then we have our formula. It's vi change in t plus 1 over 2a change in t squared, right? Then what is our vi? The velocity initially is 0 and the change in t is 1.2, right? Then plus half, remember the acceleration, we got it, so it's 6.84, and then the change in t is 1.2, and then square that. Now if you punch that in the calculator, you have 4.92 meters, right? So that's your delta x. Awesome. Now let's look at the last question. We have the cord attached to the Mercedes brakes. Then 4.3 says, what is the magnitude of the acceleration of the 8 kg mass? So now when this cord breaks here, we can see that when this cord breaks here, the 2 kg will be left alone there on the table or on the surface, whatever that is, and then the 8 kg will just continue to go downward, right, to accelerate downward. Then what they say, what is the magnitude of that acceleration of the 8 kg mass? Now you can see that when the cord breaks, there is no longer tension force, because remember now the rope is no longer exerting any force, right? So now when that cord breaks, we only have the 8 kg experiencing a gravitational force, right? So if it's only experiencing gravitational force, that means the only acceleration that is there is the acceleration due to gravity, which is 9.8. Now in grade 12, you will come to know that as free fall, right? So we say free fall is whereby an object only experiences the force of gravity, and always its acceleration will be 9.8. So having to come up with an answer for that, we say our acceleration is 9.8 meters per second squared, because the only force that is acting there is the force of gravity. So the only acceleration that is being experienced is the acceleration due to gravity. And that's it for your question, guys. All the best. Hope this covers all that you need to know. Awesome. See you next time.